Inverse of a function. What type of functions did we deal with yesterday that we found the inverse of? Were they linear, quadratic, cubic, square root? They were all linear, right? So that means today we're going to talk about nonlinear functions. So yesterday our original functions were linear. So they were just straight lines like that, correct? And then their inverse is a reflection over which line? Y equals x. So this would be flipped over kind of like that. So our inverse was also a straight line, correct? So, linear functions are functions. Or linear things are functions. Do you guys remember how we tell something is a function or not? If the x values do not repeat, then it is a function. So if you're looking at a graph, an easy way to tell if it's a function or not is to use this thing called the vertical line test. You may have learned that in Algebra 1. You should have learned it in Algebra 1. If I take my vertical line, drag it across the graph of my line, if it hits only 1 point at a time on my line, then it is a function. So there it's only going to hit 1 point at a time. Does everyone see that? So the inverse of that would also be a function because it's going to pass that vertical line test. So for today, for our nonlinear functions, the inverses of the linear functions... Oh, I'm reading the wrong sentence. The inverses of the linear functions were also functions. That's what we just talked about. Inverses are not always functions. The graphs of f of x equals x squared and f of x equals x cubed are shown below along with their reflections in the line y equals x. So here's my f of x equals x squared. Here's its inverse. Here's f of x equals x cubed. Here's its inverse. So if you notice, if you look at the inverse of f of x equals x cubed, this is a function because it passes my vertical line test. It's only going to hit 1 point at a time if I drag my vertical line across. However, the inverse of f of x equals x squared is not a function because it's hitting 2 points at the same time. The vertical line is. Does everyone see that and understand that? I'm good with that. So, we can, however, restrict the domain of f of x equals x squared to only non-negative real numbers, aka positive numbers. My voice kind of cracked there. I apologize. So if we restrict the domain to only positive values, we're only going to get the right half of this graph. Does everyone see that? Because that's only my positive x values. If I do that, then the inverse of that would be a function. So I would only get the top half of this sideways parabola. Because then it would then pass the vertical line test. Does everyone see that? If we restrict the domain to only positive values, then the inverse of f is a function. Does everyone see that? Or no? Yes. All right. Thank you. Any questions before I move on to an example? Can I move on? Example 3. Finding the inverse of a quadratic function. So we have a quadratic. The biggest exponent is 2. That's how I know it's a quadratic. It says find the inverse of f of x equals x squared, where x is greater than or equal to 0. Then graph the function and its inverse. So here they are restricting my domain to just positive values. X is greater than or equal to 0. So I'm not going to have negative values for this function. So first wants me to find the inverse. Can someone walk me through how to find the inverse? So switch the x and the y. So I can rewrite this as y equals x squared, right? And then you said switch the x and the y. What do I do after I switch the x and the y? What do I solve for? Not x. Solve for y. Got to get y by itself now. So how would I get y by itself? Square root both sides. So y equals plus or minus square root of x. Remember, we got to account for the positive and the negative value when we take a square root. But let's look at something real quick. We restricted my domain, correct, on my original function to x is greater than or equal to 0. When I take the inverse of a function, what happens to the inputs and the outputs? They're flipped, right? What happens to the domain and the range? They're flipped also, right? So if we're limiting the domain on my original function to x is greater than or equal to 0, what does that mean for my inverse function? Remember, the domain and the range switch. So if the domain of my original function is x is greater than or equal to 0, the domain switches to the what happens to domain and range? They flip. So if the domain is x is greater than or equal to 0 of my original function,
the range would be x is greater
not x.
Y.
Y is greater than or equal to 0. Does everyone see that? Because the domain and the range switch. So since my domain is x is greater than or equal to 0, my range is now of my inverse function, y is greater than or equal to 0. So is that positive or negative values? Positive. So I don't need that plus or minus sign, because we're just dealing with the positive values. Does that make sense? The domain and the range switched, so since they limited the domain, the range is now limited to y is greater than or equal to 0, since it flipped. Is everyone good with that concept? So my inverse is the square root of x, where y is greater than or equal to 0. Any questions there? What's the next thing it wants me to do? Graph the function and its inverse. So let's create a table of values for our original function. F of x equals x squared. Am I going to plug in any negative values? No, because my domain is limited to only positive values. So I'll start at 0 and just work my way up from there. 0, 1, 2, 3. If I plug 0 in, I get f of 0 equals 0 squared. What's 0 squared? 0. If I plug 1 in, what's 1 squared? 2 squared? 3 squared? 9. Everyone good with how I plugged into my original function? Okay, now I can just graph these ordered pairs. 0, 0. 1, 1. 2, 4. And 3, 9. So there's my original function graph. I only get the right half of the parabola because, once again, they're limiting the domain to x is greater than or equal to 0. Questions on that? I also need to graph my inverse. So my inverse is g of x equals the square root of x, where y is greater than or equal to 0. So let's think about values we want to plug in. It's a square root, so we're probably going to want to plug in perfect squares. So can I plug 0 in? Yep. What's the square root of 0? 0. What's my next perfect square after 0? 1, what's the square root of 1? 1. Next perfect square. 4, what's the square root of 4? 2. And the next perfect square. 9, square root of 9. 3. If you notice, we just switched our domain and range, our inputs and our outputs from our original function, didn't we? That's what happens on an inverse. So I can just graph these ordered pairs. 0, 0. 1, 1. 4, 2. 9, 3. There's my inverse function. And if you notice, just like we talked about yesterday, it is reflected over the line y equals x. Does everyone see that? Any questions about the inverse of a quadratic? Find it the same way as we did yesterday. Switch x and y. Solve for y. We good with that? All right, let's move on to the horizontal line test. So we just talked about the vertical line test. We have this thing called the horizontal line test as well. You can use the graph of a function f to determine whether the inverse of f is a function by applying the horizontal line test. So instead of holding your pencil like this, you're going to hold it like this. The inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So my blue curve here represents my original function, not my inverse, my original. And here's my vertical line. Horizontal line, sorry. If I take this and drag it down my graph, it's only going to hit one point at a time, correct? That means that its inverse is a function. Over here, the blue line represents my original function. Take my horizontal line, drag it down my graph. It's going to hit more than one point at a time, so that means the inverse is not a function. Does that make sense? And it makes sense if you think about it, because what line are these reflected over, the inverse? Y equals x. So it's pretty much turning it on its side. And so it's pretty much, it'd be like if I graphed the inverse and then did the vertical line test. It's just doing the horizontal line test instead. Same thing here. This would be flipped on its side. Vertical line test is not going to pass it. Okay? Are there any questions on the horizontal line test? We all good with that? Can I move on, or are we still writing? Good? Example 4, finding the inverse of a cubic function. Consider the function f of x equals 2x cubed plus 1. Determine whether the inverse of f is a function, then find the inverse. So the first thing it tells us to do is determine whether the inverse of f is a function. So how do I do that based on my previous slide? How do I tell if the inverse is a function? Say it again. Horizontal line test. So what do I need to do with my original function before I can do the horizontal line test? Graph it. Yep. So let's just use -2, -1, 0, 1, and 2. If I plug -2 in, What's negative 2 cubed? Positive or negative? Negative 8. 2 times negative 8? Negative 16. Negative 16 plus 1. Negative 15. So there's my first ordered pair. All right. Now let's plug in negative 1. What's negative 1 cubed? Negative 1. 2 times negative 1. Negative 2, and then negative 2 plus 1. Negative 1. If I plug in 0, what's 0 cubed? 0, 0 times 2. 0, 0 plus 1. 1. Plugging 1 in. What's 1 cubed? 2 times 1. 2 plus 1. 3. And finally, plugging 2 in. What's 2 cubed? 8. 2 times 8. 16 plus 1. 17. Any questions on how I plugged any of that in to get my ordered pairs? Not too bad. Now I can just graph them. Negative 2, 15 will be somewhere down here. So that's off my graph. Negative 1, negative 1. Right there. 0, 1. And 1, 3. And then 2, 17. Somewhere up yonder. Somewhere up there. So now here's my original function, the graph of my original function. There's my original function. How does that help me tell if the inverse of f is a function? Horizontal line test. If I take my horizontal line and drag it down my graph, it's only going to hit 1 point on my graph at a time. It's never going to hit 2 points at a time, is it? So is it a function or not a function? Function. So I'd say the inverse is a function. Because it passes the horizontal line test. That'd be my explanation. Any questions on that? What does it want me to do after I've told whether it's a function or not? Find the inverse. So can I erase all this stuff to the left? I have y equals 2x cubed plus 1. What do I need to do to find my inverse? Switch x and y. X equals 2y cubed plus 1. And now I'm solving for x or y. Y. Solving for y. What's my first step to get y by itself? Subtract 1 from both sides. What's my next step?
Divide by 2.
Divide both sides by 2. And my last step. Take the cube root of both sides. So I get y equals the cube root of x minus 1 over 2. Is this in simplest form?
Yes. No.
Why is it not?
And break it up.
Do what?
Can't you break it up?
I can break it up to where my numerator and my denominator are under their own radical. Why is that a problem?
Wait, I mean, like, wouldn't it be x over 2 and then negative 1 over 2?
You could do that. But let's think about it this way first, real quick. I could break them up into their own radicals, right? Do I want a radical in the denominator?
No.
No. So I'd have to multiply by the cube root of 4 over the cube root of 4. Cancel out my denominator, or the radical in the denominator. For today's purposes, I'm okay if you leave it like this, because I just want you to be able to do the work to find the inverse for right now. Just know that this is not in simplest form. Has everyone got that? If you split it up, like we had talked about the other day, that'd be an even bigger mess than doing it this way. So we still don't want it like that for these purposes. Questions on example 4? Can I move on to my last example? Last example for today. Consider the function f of x equals 2 times the square root of x minus 3. Determine whether the inverse of f is a function, then find the inverse. So once again, what do I need to do? What was my first step on the previous example? Graph the original function, yep. Then use my horizontal line test. So I have an even root here. I got the square root. Do I want negatives under an even root? No, I can't have a negative under an even root, can I? So what values of x can I plug in here? I can plug in 4.
0.
Could I plug in 0?
You said it can be what? 7?
I can't have a negative under my square root.
7.
I can plug in 7, yep. What values can I not plug in?
Negative.
Can't plug in negatives.
2.
Can I plug in 2?
Numbers less than 3.
What?
Numbers less than 3.
Numbers less than 3 I cannot plug in. Let's think about it. If I plug in anything that's less than 3, plug in 2 for example. 2 minus 3 gives me a negative number. 1 minus 3, negative number. Anything that's less than 3 is going to give me a negative, correct? Because I have that minus 3 in there. What happens if I plug 3 in? 0. Can I have 0 under a radical? Yep. So let's start with 3. 3 minus 3. 0. Square root of 0. 0 times 2. 0. What could I plug in that would give me another perfect square under my radical? 4. 4 minus 3 would give me 1. Square root of 1. 2 times 1. Everyone with me? What number could I plug in to get my next perfect square under the radical? 7. 7 minus 3 is 4. Square root of 4. 2 and 2 times 2. Is everyone seeing where I'm getting these numbers to plug in? And what would be my next number? 12. 12 minus 3. 9. Square root of 9. 2 times 3. 6. Everyone good with that? All right. Let's graph these ordered pairs. 3, 0. 4, 2. 7, 4. And then 12, 6 will be somewhere to the right of that little dot right here. Everyone good with that? So there's the graph of my original function. How do I determine whether the inverse of f is a function? Horizontal line test. Is this only going to hit one point at a time, or is it going to hit multiple points at a time? Only one. So is the inverse a function? Yes, it is. So I'd say the inverse is a function. And my reasoning would be because it passes the horizontal line test. Everyone good with that? What would the domain of this function be? We already kind of talked about it earlier when we were talking about the values to plug in. What? 3 to infinity, where 3 gets a bracket, which could also be represented by x is greater than or equal to 3. What's my range here? What? Range is my y values. Is there a stopping point going down? 0. Is there a stopping point going up? No. So it'd be y is greater than or equal to 0. Or 0 to infinity, where 0 gets a bracket. Everyone good with that? And what's the last thing I need to do? Find the inverse. So I have y equals 2 times the square root of x minus 3. What would be my first step here? Switch the what? Switch the x and the y. Now what could I do? Divide by 2 on both sides. 2 is being multiplied by that radical. So I have to divide by 2 to get rid of it. So I get x over 2 equals the square root of y minus 3. Can someone raise your hand and give me my next step? Square both sides to get rid of that radical. Remember, when I have a quotient squared, I just square the numerator, square the denominator. So x to the second power would be x squared. 2 squared would give me 4, which equals y minus 3. What do we say? Add 3 to both sides. So y would equal x squared over 4 plus 3. And we want it as a function, so we'll call it g of x. G of x equals x squared over 4 plus 3. There would be my inverse. So what would be the domain of my inverse here? Nope. Remember, domain and range switch. So what was the range of my original function? 0 to infinity. So the domain would be 0 to infinity. What would the range be? 3 to infinity. Everyone good with that? Not too bad? Can I move on to our assignment? Y'all are ready for the assignment, aren't you? We're done with notes for today, though. There's our assignment. This will be due Thursday, May 6th, on campus.
We should have a catch-up day. I feel like we've had a lot of work.
Yeah.
Are there any questions before I end the recording?
Do we have to catch up there?
About the notes?